So good afternoon everybody, myself Acharya Vishwanath. Let's discuss today questions based on thermodynamics. So this is NCERT line discussion, chapter thermodynamics. So the first question deals with thermodynamics itself. Then there is a concept of heat, then a steam engine. Earlier concepts of heat are used. Then some experiments based on heat. Then Benjamin-Thompson experiment. Then we have caloric picture. Then we have questions related to Benjamin-Thompson experiment. Then we have explanation for heat produced. Then Benjamin-Thompson experiment. Then we have certain things about the thermodynamics. Then quality of thermodynamics, whether it is microscopic or macroscopic. Then with what things thermodynamics deals with. Then we have the year in which laws and concepts of thermodynamics were formulated. State of a gas. Then we have relation of temperature. Then equilibrium system in thermodynamics. Then a gas enclosed inside a closed container. Then state of thermodynamic equilibrium, adiabatic valve, diathermic valve, thermal equilibrium, zeroth law, heat flow, internal energy. Internal energy is with respect to which frame? Internal energy of a system includes internal energy of a system is represented by internal energy of a system is. Then thermodynamics state variables are. Then ideal gas internal energy is. Then a gas in motion possesses which type of energy. Then how to change internal energy. Then state of thermodynamic system, alteration, heat, state characteristics. And then some meaningful, non-meaningful statement. Then it's about heat work in both. Then about an ideal gas contained in a box. Then we have first law of thermodynamics, delta U, graphical variation of volume of water, then density of water variation, then coefficient of volume expansion, then relation between alpha, beta, gamma, then thermal stress, then increase in temperature, then thermal strain, then internal force due to heating, then areal expansion coefficient, then ring problem, then heating of water, heat capacity of a substance, dimensional formula for heat capacity, then SI unit of heat capacity, then specific heat capacity of a substance. Then we have dimensional formula for specific heat capacity. Then we have SI unit of a specific heat capacity. Then dependency of a specific heat capacity, then molar specific heat capacity. Then we have SI CGS unit, then CP, CV, then for water. Then there is concept of convection, then different type of systems, calorimetry, questions based on calorimetry, graphical question based on calorimetry. Then we have melting point, freezing point. Then we have latent rate of vaporization. Then we have questions based on the phase diagrams of water, liquid state, gaseous state. Then we have steam formation or boiling. Then we have the process for increasing impact of increasing pressure on boiling point. Then declination in boiling point, pressure cooker concept, change from solid to vapor state, sublimation, during sublimation, latent heat dependency, transfer or transition of a matter of ice into steam, and latent heat. Then we have dimension formula, SI unit, dependency, latent heat from solid to liquid, liquid to vapor, numerical questions based on that. T1, T2 and T3. Heat is added to a substance during change of a state. Then we have concept of questions based on some calorimetry problems. Then we have conductivity of materials, plastic forms, insulators, conductors. Then we have Fourier's law, numericals based on that, graphical questions based on that, graphical question on the thermal resistance with different correspondences. Then we have two combined slab problems, their interface temperature, thermal resistance, heat current, junction temperature. Then we have equivalent thermal conductivity, then convection, possibility forced convection, equator and poles, velocity of trade, transport medium requirement, radiant energy, black object radiations. Then we have questions based on thermals concept. Then we have Newton's law of cooling, its graphical variations. Then temperature is a function of time. Then we have certain questions based on that. Then we have dimensional formula of amount of substance, SI unit. Then we have thermal conductivity, temperature, conduction, convection, etc. So a total of 250 questions are there in the chapter, and if you prepare optimally, then you can save your precious time and energy, and can prepare in more object-oriented way, which is the driving force behind all these video series. So basically this NCRT question series is meant for preparing NCRT in an object-oriented manner, because language of NCRT is a bit complex and it takes a much high amount of time and energy. So these questions are designed so that you look for specific information in NCRT and have a inbuilt task so that your mind doesn't wander and you can perform better. I hope it works best for you. Thank you and have a nice day.